Okay, hello everyone. We still got a minute to go before we officially start, but already hello from Germany and from the States. And give us a minute, give the others some time to join the webinar, and then we'll get started in just less than a minute. Okie doke. So let's get started. I'm Ramin Esmaili from Softing Industrial. I'm the head of marketing communications here. Together with me, I got our friends, partners from Peakboard. So I got Nina Berger in Chicago, managing director, Peakboard America. Hi, Nina. And I got Thilo Brosinski, sorry, head of development here in Germany. And my colleague just around the corner, Stefan Gebele, solution engineer at Softing Industrial. We'll spend the next 1 hour together. It'll be about CNC machine data dashboarding. We'll have about an hour or maybe a bit less where we'll present the part on softing, on how we access data from CNC machines and make it available for upper level software applications via standardized interfaces. That's our part from softing. And then our friends from Peakboard will show how that data then can be created for IoT applications such as dashboards, and how that is pretty straightforward and easily done without really having to have much programming knowledge. Yeah. As you kind of soak this up and listen to us, enjoy the webinar. And if there are any questions coming up, feel free to post those in the chat. We'll attend to them towards the end of the webinar, so we'll have enough time for that. We will also provide a recording of the webinar and the presentation. We'll send that out to you. And I would say that's pretty much my 1 minute of fame, and I'll give over to Stefan as of here. Enjoy the webinar.
Thank you very much, Ramin. So I should share now my screen. Yeah, thanks again. My name is Stefan Gebele. I'm solution engineer with Softing, and today we are going to talk about how to collect data from SINUMERIK 840D. But before we start, one question: why is data collection important? Let's assume that your company asks you to introduce machine learning or to train your AI model, or simply, like we do it today, to visualize data to monitor if your production targets are reached. All these use cases have something in common. They all need high quality data in the beginning. To overcome this challenge, Softing provides multiple solutions for it, like the edgeConnector 840D, a Docker container software, which is used to collect data from 840Ds, SINUMERIK. With the edgeConnector 840D, you can access solution lines as well as power lines, 32 types which are available. This power line is a little bit older. Solution line is everything after 2005, roughly. With the edgeConnector 840D, you can easily access data like from the access, from the drives, from the program data and the conditions and the tooling, and you can provide this data via OPC UA and MQTT. The edgeConnector is a modern lightweight Docker application which allows you flexible management and deployment via Docker Hub or the Azure IoT Edge, as well as AWS Greengrass. The configuration is done via a web interface, so all what you need is a browser. You don't need separate software to configure the the edge connector, you can also automate things by using the integrated REST API. Softing has more edge connectors, not only the edgeConnector 840D, it's a whole edge connector family, which is also increasing over the years, and further developments are planned. So we have an edge connector specifically for Modbus PLCs, we have an edge connector Siemens for Siemens PLCs, and we also have an edge connector for FANUC CNCs. But of course, today we focus on the 840D, which is highlighted here. Speaking about the setup, so the edgeConnector 840D needs to make a connection to both, or you can select it actually to PLC and CNC. So the SINUMERIK consists of these two parts, and in order to collect data out of it, you need to physically connect it to the interface called X120 or X130. I will show you a picture on the next slide which show it in more detail. As said, you can use both X120 as well as X130 interface. If you use the X130, then please ensure that the firewall is enabled of the SINUMERIK. That's how it looks in real life. So we have the X120 and the X130. The X120 on the right side, you see there's a yellow cable plugged in, and the X130 would be the white cable here. When it comes to power line, this is also possible, but you need a separate hardware device. Why is that? Because the power line does not provide Ethernet interfaces. So you need some sort of adapter converting the MPI to Ethernet, and this can be done with the Softing NetLink, which is converting serial to Ethernet. You will plug it in on the X122 interface, and you select a baud rate of 187.5 kilobits, and then you are good to go, and the edge connector can collect data also from power line. Some real-life photographs. You see the front panel. It looks pretty much the same of all power lines. You have the X122 here. It is always right above this 8-digit display, and if you connect our hardware adapter to it, it looks like this. And as said, it is converting the MPI bus to Ethernet, and then via the yellow Ethernet cable, we collect the data. You may ask how to collect the data. Now we have physically connected, but how does the edge connector know which data to retrieve? And this is done via two files. So we have the SDFI file for collecting data from PLC, and we have the AWL file for collecting data out of the NCK part. So actually two files for the two different areas. Let's have a look how the SDFI file look in more detail. So if I open it up, the SDFI file looks like this. You have the program running, which is the tag you want to collect, and you have the data block where it actually stored in the byte and the bit. So program running is a Boolsche bit, which is either true or false, and this is the address of it. You need to know that, and you need to tell our edge connector where the information is stored. We will cover this later on again. So program running, program stopped, and also the workpiece counter is handled separately in a few minutes. Let's have a closer look how the AWL file looks, and you will notice it is a bit different. Also, the address here is different, of course, because the NCK part is of other design. So the address space needs to be here enlarged and also differently. Where do you get this data from? You get it from the NC var selector, a tool which comes from Siemens, and I will also speak a few words about this in a second. So once you have created these files, you can simply import it into the edgeConnector 840D, and you will then collect data out of these two areas. So the next question is, how do I get the files? And this is easy because you can simply download it from our website, and you don't need additional tools if they meet your requirements. So you get default files from us. Pretty much they have been developed together with customers, and it fits for most use cases. But of course, if you need special variables, you can enlarge or can change it, but it can serve as a template. So if you want to adjust your AWL file, or you want to have more variables, you can use our .var file, which you can also download. You can import in the NC-var selector, and then you can add some variables, you can delete some, whatever you want. The NC-var selector is a tool by Siemens, so you need to ask Siemens to get this program. It's easy to operate, and what gets out is the AWL file. This file is later then imported into the edge container. The same is for the SDFI file, but you need a different tool. This one is developed by Softing, and you import your project of the PLC, your Step 7 project or your TIA project, and then you get a list of all available variables. You can easily tick the boxes, which variables you want, and then hit export, and what you get out is a SDFI file, which is then imported in the edgeConnector. This is pretty much everything from my theory part. I will come back with the practical part, but first I hand over to Nina.
Thank you, Stefan. I'm gonna share my screen. Can you see?
Perfect.
Perfect. Yeah, I'm Nina from Peakboard America. I'm also introduced Peakboard to you today. We are talking about data collection. So what Peakboard does is help you to get data from many different data sources. That means maybe your data is in like machines, ERP systems, and so on. So Peakboard can pretty much help you collect data from lots of different systems. Also, if you want to do the first step into automation, get rid of paper reportings, here Peakboard is a great solution. Our value proposition is pretty much like a low-code platform. It's a software, easy to use. You can pretty much connect your systems and create individual dashboards. Individual, that means like perfect match to your use cases. On the right side, you can also see like an interactive dashboard. That means Peakboard is like you can pretty much interact with the machines, start processes, and also write data back to the system. So it's not only visualizing, we can pretty much also communicate the data back to the systems. Here you can see Peakboard regarding like the automation pyramid. So we can connect sensors, we can connect machines with Peakboard, but also ERP systems and MES, so that you have like an idea where Peakboard focus on. How does it work? I already mentioned that. It's like a software where you're gonna create your individual dashboards, where you're gonna collect your IT systems, your machines, your CNC machines, for example, and also maybe your ERP system. And then you have the chance to create your individual dashboard, very interactive or focusing on more transparency. And then the next step is that you upload your Peakboard project with the full logic and connectivity. That's what we also show you later in this webinar, to our hardware, the Peakboard box, which is a single board computer connected to a standard screen or touch screen. Communication is via Ethernet or Wi-Fi. I have like a picture here. How does it look like in action? The Peakboard box connected to a touch screen. And then here, this is with interactivity. So you can pretty much choose the tasks and interact with Peakboard and communicate the data back to your systems. Some of our data sources, we have also a full list on our website as well. And I want to show you a few examples here. This is an interactive example showing an overview dashboard with different workstations. The data here is from SAP, but it could be any other ERP system as well. So you can see the different workstations, and then on every single workstation, you have this, could be like a touch screen, also Peakboard box connected, and then the operator can like start the process, stop the process, report error messages, and Peakboard communicates that data in real time to this overview dashboard. You can pretty much send alerts. In this case, a tool is missing on station 2. And then the next step could be that Peakboard sends you an email notification, push-up notification on your phone, and so on, so that you know exactly what's going on. This is another example here with like quality control. Here you can also interact with Peakboard. You can see that here, push the button when something is incorrect, and then also send alerts as well. Yeah, here is already the example from the technical part. I'm gonna like Tito is taking part of the technical part later and shows you how he did that example. Thank you. I hand over back to Stefan.
Thank you very much. Just give me 1 second. Yes, okay. So this is now the practical demonstration. I have now connected to my edgeConnector 840D. How did I that? It's easy. You just have to open up your browser, type in the IP address and the port under which the edgeConnector 840D is running, and you are asked to enter your username and password, and then you come to the landing page. It gives you some useful information like, yeah, it's the edgeConnector 840D, not the edgeConnector Mopus or the edgeConnector Siemens. It is in status running, and it runs as a demo mode. So by the way, you can simply download and test it for 72 hours. You don't need to buy it directly, which makes sense. Due to the limited time, I can only cover this section called connectivity. And as mentioned earlier, you can provide the data via MQTT and also via OPC UA. Inside the controller section, you add a new connection by hitting this Add Connection button. I give it a name. In my case, it is Solution Line. And now I can select to which area I want to connect. So NCK only or also PLC. Of course, I want both. And I use the default one for the controller connection, the default SDFI file. But I have changed a little bit with regards to the AWF file, so I will use that one. What I did is I just have added one more item to this list. So I'm using that one, and the last what I have to do is enter the IP address of your solution line. You may ask, how do I connect to a power line? Just go to the advanced setting chapter and select, instead of solution line, power line. So for the TSAP, this is a special Siemens setting, TSAP, NCK, TSAP, PLC. Yeah, change it to power line. So you have also the possibility to enable NCUR alarms and also NCK tooling access. I will show you in a second what is meant by this. So will I enable this both? I go back to the connection settings and hit save. And you see now the connection is open, but now it has connected. So successfully, the plugs are together and everything should work. Now I switch to the OPC UA section where you can configure your OPC UA server. The edgeConnector serves as an OPC UA server, and each client, each OPC UA client can then connect to it and collect the data. So when it comes to security, of course, you can configure the UA server that it's only forwarding data in an encrypted way, and also the authentication settings can be adjusted. In my case, I leave everything to anonymous, and also the security policy is none. What is also possible is to restrict the access rights. So in my case, I could say that no read access is granted and no one is able also to write data, which makes more sense than restricting the read access. Furthermore, we have implemented some IP access filter and also access protection, denial of service to enlarge security here. The next step is to simply copy and paste the URL of the OPC UA server. And now I open up my OPC UA demo client. It's a freeware. You can download it from our webpage. It is only there to check if data is coming fine and if you have good quality. But of course, this tool, this OPC UA client, is for free and you cannot create nice draw graphs. For that, we have some partnerships like the one from Peakboard, which can do more with the data and more do the visualization part. So I hit OK, and now it is opening up the address space of the OPC UA server. I will start with the PLC first, and you see again here we can check if the program is running, which is true. So currently there's a program running. It is not stopped. It has not been interrupted or aborted. So it gives you a little bit of an overview. Interesting information from the NCK is, for example, the program which is currently running. So this is the name of the program. This is the actual line number which is currently executed, and this is the line content. Also, the workpiece in place is listed here, and furthermore, we can access the position of the different axes. And this is also changing its value because the program is currently running. Speaking of the alarms, that's what I've previously enabled, which allows me to collect all the alarms which are currently present on the SINUMERIK. As I'm using a demonstration, it is pretty much not meaningful, but you can get a glimpse of it by looking at the first line. It means that you get a date, you see if the alarm is active or not, and then you get a number, and if the text is available, you will get the error message. Let's head over to the tooling area. We have also information which is collected there. We have different tools in different places, and for each place we can see, okay, which tool is currently in place 1. It's a tool number 4, and this is the German word for it. It is a specific tool, and it is also monitored, like there's this time monitoring, and it tells me pretty much how fast how much I can drill until the tool needs to be replaced. So all this information is there, and now I hand over to Thilo, who is going to show you how you can visualize the data.
So thank you, Stefan. And yeah, I will now proceed by showing you how we can use this data now with Peakboard. So for that, already opened the Peakboard Designer. It's our software you can download for free on our website. And the first thing I will do is step into the main window where I firstly will add a floor plan by just drag and dropping it from the File Explorer from Windows directly to the Peakboard Designer, which allows me to use this file here in our software. So that's the floor plan, and here we later want to show the data from the SINUMERIK. So first thing I do is right click on it and select log, so it doesn't annoy me anymore. So I cannot click here anymore because it's just part of the background. So the next thing I'm going to do is add the data source. For that, I'm just clicking on data, add data source, where I can select the data source I want to use. So you can see we offer different data sources, like, for example, REST APIs for connecting different MES or ERP or whatever kind of systems, the ERP system like SAP, but also databases like SQL Server, Oracle, and so on, Excel files, and a lot of different machine data. And like this, we will use now OPC-UA because that's just the way we're getting the data from the Softing edgeConnector. So let me just call this SIN1 for the SINUMERIK 1. And first thing I need to do here is enter the enter the URL of the OPC-UA server, and then I can just select certificate, which allows me to connect to this server. Like Stefan showed before, he set it up as anonymous, so that's what I also will do here. So now I'm able to click here on Manage Subscriptions, which allows me to browse through the OPC-UA server and check out all the data here. So in that case, we have this SINUMERIK, and I want to use this for variables. This is the program run, so everything is fine, the waiting and the stop, so if we have any kind of issue. And also we have here this workpiece counter. So let's select those and click here on Enable Listener, which directly creates a connection to the OPC-UA server to really get the live data out of it. When I now click on the OK button, I just created the data source here on the left side. So the next thing is that I want to create a rectangle. For that, I just taking it from the top and moving it on the floor plan on the position where the SINUMERIK is placed. Then I will do just some visual settings by setting the border size and the border color here on the right. And also I will add a header for that. In that case, I will just place it on the top of the rectangle and center it. Also, I give it another font. In that case, it's a little bit too big for me. So I just changed the font size here, clicking here. And also, of course, I changed the name to SINUMERIK. So now I want to show the workpiece counter. Stefan already shown on the edgeConnector side, and this one I want to show here in this rectangle. For this, I again centered the text, adding a text here from the top, and in that case, I want to connect this text to my data source. For that, I can just click here on this button with the chain. And in that case, I have just one data source, so that's exactly the one I will select. And I want to get the workpiece counter out of it. So here we have this data. The next thing is that I want to show if we have any issues with our machine or if everything is fine. For that, I add some ellipse here on the bottom right of this rectangle, and I'm just placing it here on the bottom right, and by default I set the background color to green, which means everything is fine. But of course, static background is not useful most of the time, so for that I can use this conditional formatting you can find for all of our Peakboard controls here on the right side in this properties, and I click here on this button, which allows me to create some rules. And the first rule I want to create is the OK state. In that case, we have from the SINUMERIK the program running Boolean on true, and in that case I want to show the background green. Let's add another rule for waiting. So this is the planned stop of the machine. In that case I want to the Boolean waiting will be true, and in that case I want to set the background to yellow or to orange. And the last one is the arrow state. So I call this arrow and select the stop variable here. In that case, this one is true, and then I want to set the background color to red. So that's basically all I need to do here. So now let's go one step forward, and we don't have just the data from the OPC-UA server, but we also have some manual workplaces here. And for that, I will just create another rectangle, which will later show the state of a manual workplace. So let me again place it on the position where the workplace is, give it again a back border, and put it here. So now again, I will first add a header on that part, placing it again on the top of this rectangle, and then let's just place it here on top of the rectangle and center it again. So we'll do this here, change it to the same font as in the button, and here I call it Workplace 1. And now I also need to get this data somewhere. In the case of the SINUMERIK, I get it from the edgeConnector of Softing, and in case of the workplace, I want to create a dashboard where the worker can directly send the data here to the dashboard. So for that, I create just two variables. The first one I call workplace 1 counter, and I set the data type to number. And I go here to advanced, and I click here on share via Peakboard Hub, where I can define an identifier, which makes it possible to connect it to another dashboard later. So I will call this workplace 1 counter. Let's just add another variable for the state. So in that case, I call it workplace 1 state. Again, I set the data type to number, and again, I set here an identifier, and I call this workplace 1 state. So now I can proceed by using this both variables by just dragging it on the canvas here from the left side, and now I placed it on the wrong position. Let's call it again workplace 1. Give it another shot. Here, let's place it here, the counter on the bottom of this rectangle. And again, I will center it and proceed with the state by adding again such an ellipse here on the bottom right of this rectangle. So, and here again, we just place it on the bottom right and set the background color to green for the default value. And in that case, I go back to this conditional formatting, where I now have again the possibility to change the color based on the current state of the workplace we later will get data from. So again, we call the first state running, and we just set it here in the variable workplace 1 state, and it was already defined before that the number 1 defines the running state. So I will do the same for a waiting state. In that case, the state will be set to 2. Then we want to show it as yellow or orange. And the last thing is an arrow state. So if the worker has any kind of issue that you directly can see, you need to act somehow here, then we set this workplace state to 3. And then we want to show here a red light on this workplace. All right, that's basically it from the dashboard perspective, but for the workplace, of course, we also need to collect the data somehow. And for that, I've already shortly prepared a small application here. And here you can also see this both variables. So we have here this counter and the state. And in that case, you just can see here we connected them. Oh, sorry, I'm on the wrong language. Let's go back. Here you can just directly see that we've used the same identifier on both sides. That's why we can just mix these variables from two different dashboards together. And when we just go in such a button, so here we have 4 buttons, and let's just step in one of those buttons to see how the logic behind is looking like. And you see it's pretty simple. So we just set the variable state to 1 for OK, or we set it to 3 for the problem. And then we also have this button for done. Let's go into that one. And in that case, we just set this counter variable with here on the left side, and we just counted 1 up. And when we are done with that, we can simply upload it on any Peakboard device, like for example, this surface I have here next to me. I can just click here on upload, click on the device where I later want to use this application and upload it here. And after a short, after a second, you can just see the dashboard here on that side. And then let's go back to our dashboard. I clicked here on preview to get a live preview of the application we've created before. It will just take a second. It will now connect to the edgeConnector for getting the data from the CNC machine, but also we've connected these both dashboards by using this identifier before. So like you can see here, we got the amount from the PLC, from the CNC, and also we have this workplace here on the top. So when I just click here, for example, on this done, then I can see that I missed something. Maybe I've used here the wrong name. However, this is easy to solve. So let's just shortly jump back. And let's go and give it another try. And then afterwards, you can see the changes directly from the workplace, going back to this overview here by clicking on this button here on my surface. It's going back there, and also you can see here the data from the edgeConnector. Yeah, and that's basically all I wanted to show for now. Thank you.
Yeah, great. Thank you very much, Thilo, for this detailed and very good presentation. I'm going to check for the questions which are coming in. So I think I have got here one for you, Stefan, which is asking, how many connections can I configure in one edgeConnector?
Yeah, very good question. Yes. Well, actually, in one edgeConnector, you can collect up to 20 SINUMERIKs. If you need more, then simply start a further instance of the edgeConnector.
Mm-hmm. And I have one further questions also coming in. So either to Thilo or to Nina, it's asking, can I also clean the data in case I want to aggregate them for further use?
I think that's a good question. So it very often makes sense to clean the data somehow because you don't get it directly as you want to use it. For that, we use so-called data flows. So you can just go on the data source you've created and click here on proceed data with a data flow. And in that case, we offer different ways to manipulate the data. So for example, you can filter your data, you can sort your data, aggregate them like you've asked for, or connecting different data, like for example, the SINUMERIK together with your ERP system or whatever.
Okay, great. Thanks. Okay, so let me just see, dramatic pause of 1 or 2 seconds to see if I get any further questions in, which doesn't seem to be the case, so I think we're good. I thank everyone who's participated in today's webinar, and especially thank you to Nina, thank you Thilo, thank you Stefan. Do look up our website, Softing Industrial, in case we do, if you were interested in further future webinars, which we do with our partners. I hope to see some of you back in one of our future webinars. Everybody here in the group, have a great day, and till next time. Bye-bye.
Thank you, Ran, and thank you to the
Thank you very
audience.
much.
Bye.
Bye.
Bye-bye.